Um, yes, students, we are going to see the worksheet on relative velocity that we are already given. Motion in a plane. So there are 11 questions. We'll try to quickly solve this one. I will give you some tips about how to solve this. So the first question. Open car is moving on a road with a speed of 100 kilometers per hour. So there is a car which is going at a speed of 100 kilometers per hour. A man sitting on the car fires a bullet from the gun in opposite direction. So there is a firing which is happening here in the opposite direction at a speed of 250 kilometers per hour. Right? Now it is relative to the car. This is already relative to the car. This is a relative velocity. V, there is the firing of gun related to the car. So what is the speed of the bullet which has been going in this direction? So the speed of the bullet will be speed of bullet with respect to the observer. It is going to be equal to 250 minus 100. It is 150 kilometers per hour, because it is already an added speed of 100 plus 150 together. That's what it is. This is an added speed because it is a relative velocity. So the final thing will be 150 kilometers per hour will be the speed of this one. We'll go to the next question. Car A is moving with a speed of 60 kilometers per hour and car B is moving with a speed of 75 kilometers per hour along the parallel straight path starting from the same point. So this is two are important. Starting from the same point along the same parallel path. So this is second point. So there is a car which is here heading on. This is car A moving with a speed of 60 kilometers per hour. And then there is another car going. This is car B that's going at a speed of 75 kilometers per hour. Now we'll see what the next part it is. What is the position of the car A with respect to B after 20 minutes? 20 minutes later, what will happen to this car? What is the position of car A with respect to car B? So car A where it will be, car B where it will be, it is asked. So what first of all you need to do is put this car A into rest by imposing equal and opposite velocity here. And this equal and opposite if you put here also you need to put the equal and opposite, minus 60 kilometers per hour. So the net speed of this one, the net speed of B, velocity of B with respect to A is going to be equal to 75 minus 60. It will be equal to 15 kilometers per hour. This one relatively velocity becomes 0. The relative velocity will become 0. Here this will become 15 kilometers per hour. Now in this one it is already going, and after some time this car, so this car will be somewhere over here. What speed it is traveling? It is traveling with a speed of 15 kilometers per hour. Just 15 kilometers per hour it is traveling. So look at the question again. The question says the time taken is 20 minutes. So the time taken from here to here it is 20 minutes. In other words, it is 20 upon 60. That's going to be equal to 1 by 3 hours. So what is the position? It will be here. So it is velocity is given here. The velocity of B with respect to A is equal to 75 minus 60 is equal to 15 kilometers per hour. The next one is time taken is equal to 20 upon 60 is equal to 1 by 3 hours. So what is the next one? You need to find out you have to find out the distance. So distance is equal to velocity into time. So what is the velocity here? It is 15 into time is 1 by 3. So it's going to be equal to 5 kilometers. So distance is going to be equal to 5 kilometers. So this will travel for 5 kilometers with the speed of 15. So after 20 minutes you will see this car B will be here and car A will be here. Car A will be how much distance behind? 5 kilometers behind. So car A will be 5 kilometers behind B after 20 minutes. So it's so important. How do we do this one? Is we put one car into rest and we change the entire velocity of 75 into the rest velocity. This is the rest of the velocity is only 15. So with 15 this one only moves. It is very easy for us. Only this moves with 15 with a distance of with the timing of 20 minutes. So it is going to be only 5 kilometers away. So that's the way it has to be done. We'll go to the next question here. So two buses start simultaneously towards each other from town A and town B, which are 480 kilometers apart. So this is town A, this is town B. One bus is going from here, so town A to B, so this is going to be VA is the velocity. Another bus is coming from here, this is VBB is the velocity. So both the towns are at a distance of 480 kilometers. It's already given here. The first bus takes 8 hours to travel from A to B. So this one will take 8 hours. And the second bus takes 12 hours. This will take 12 hours. Now keeping this into mind, we will be able to easily say how much is the speed of bus A. It's going to be equal to distance upon time, 480 upon 8, 60 kilometers per hour. Speed of bus B, it is distance upon time, 480 upon 12 hours. So it is 40 kilometers per hour. So you find here this is going to be 40 kilometers per hour. This is going to be 60 kilometers per hour. Now we'll read the question further. Now determine when and where the buses will meet. When will the buses meet? So what we can do is, if this is 40 kilometers per hour, let us put this bus into rest. Minus 40 kilometers per hour, and here also in this direction 40 kilometers per hour we need to put. So this becomes at rest. Only this is moving now. When this is moving, how much the speed will be there? It is totally 100 kilometers per hour it will move. This is the speed, total speed, relative speed. Relative velocity of A with respect to B is equal to 60 plus 40, 100 kilometers per hour. So in this 100 kilometers per hour, it is just starting from B. It has started and we already put this into rest. Only this is going to travel to this place. So how much speed is going to travel? 100 kilometers per hour. So 100 kilometers per hour is the speed. Distance is equal to 480 kilometers. So what is the time taken? Time taken is going to be equal to distance upon velocity. So distance is 480 upon velocity. So it is 4.8 hours you get here. So the answer is 4.8 hours. The next one is, you also have to find out where it will meet. What is the place it will meet? Now in this point, when you are going to see the distance travel from here to here, where this bus will meet. Now we will remove the relative velocity principle when you are going to find out where it will meet, because this bus is already going to go with the speed of 40 kilometers per hour. This bus is already going to go at the speed of 60 kilometers per hour. Now it is taking 4.8 hours to meet. This timing is there. Now with this timing, you're going to put in this bus, maybe the bus A, but we cannot take 100 kilometers per hour here when you're putting this distance traveled, because you cannot put this way. You have to put only 60, because we wanted to find out when this bus is already heading on towards one position. Maybe this is the position here. Let us consider. With 40 speed, after 4.8 hours, it would have reached here. After 4.8 hours, this would have reached here. Now when this is reaching here, how much speed it takes? Only 60 kilometers per hour. So we are going to take only the individual speed of the bus for the second calculation, where it will meet. So timing is going to be equal to 4.8 hours, and then speed is equal to 60 kilometers per hour for the A velocity, or maybe velocity A. And so you can calculate this one. So once you calculate this one, the distance traveled, how much distance it will travel, it is going to be equal to distance is going to be equal to velocity into time. So it is going to be 60 into 4.8. You will get 288. Will be the answer. Kilometers will be there. Right? That's the distance it will be. In this distance, from A, it will meet. So from A, at a distance of 288, it will meet. So that's the next question. Question number 4. Two trains A and B, each of length 100 meters, are running on parallel track. One overtakes other in 20 seconds, and one crosses other in 10 seconds. Calculate the velocities of each train. So let us take one train. This is train A. This is also 100 meters. And then train B. This is also 100 meters long. This is both the length are the same. Now when it overtakes, so when it is overtaking, something is happening, and then when it is crossing each other, so A is here, B is here, 100 meters, 100 meters. When it is crosses here, that means it is going in opposite direction. Here this is going in same direction. So opposite direction when it goes, it takes how much time? It takes 10 seconds. And here it takes how much? 20 seconds to overtake. So with this one, we can easily find out the velocity of the each trains. Now let us consider this is VA and this is VB, and here this is going to be VA and VB. Whenever they are going in the same direction, what you will do, it is VA minus VB is a relative velocity. So this is going to be same direction, and this is going to be opposite direction, relative velocity. What is the relative velocity when it is opposite direction? VA plus VB. And what is the distance? It is just both of them is going to cross each other. So when it is crossing each other, if you see, so it will start from here. This B will be here initially. This will be the one. So 100, and this is 100. So totally after some time it will be here. So the total distance is this much distance it has to travel. 100 plus 100. It is 100 plus 100. 200 meters. So the distance traveled is going to be equal to 200 meters for both of them. Now time taken, it is going to be equal to 20 seconds here, and time taken is going to be equal to 10 seconds here. So we need to calculate both the things together and find out the answer here. So as you find out the answer, so VA minus VB is going to be equal to distance upon time. Time is 20, and VA plus VB here, it is going to be same distance upon time is 10. So this will be, it will get cancelled out. You will get only 10 here. This you will get equal to 20. So there are two equations you will get here. So VA minus VB is equal to 10. VA plus VB equal to 20. Solve these two. Once you solve these two things, you will get VA, you will get an answer. You will get VB, you will get an answer. These two will get cancelled out. 2VA. So 2VA is going to be equal to 30. What is VA? That's going to be equal to 15 kilometers per hour. And what is VB? Then it's going to be 5 kilometers per hour. So you will get the answer like this. That's already here there. 15 and 5 is the answer. Not kilometers per hour, it is meter per second. It is meter per second. The next question, question number 5. A man swims in a river with and against water at a rate of 15 kilometers per hour and 5 kilometers per hour. With the river, when he flows, when he swims, man with the river, that is going to be equal to U plus V is equal to 15 kilometers per hour. Consider what is U, speed of river, and what is this one, speed of man. The next one is man against the river. What is that? It's going to be equal to V minus U. That's going to be equal to 5 kilometers per hour. So we have to find out what is the speed of the water and what is the speed of the river and speed of the man in still water. So you just add this one. When you add this one, you will get 2V is equal to 2V is going to be equal to 20 kilometers per hour. So what is V is going to be equal to 10 kilometers per hour. So that's the speed of the man. Speed of man. And next one is speed of river. Speed of river. That's going to be equal to U. It will be 5 kilometers per hour. You'll get this answer. Question number 6. A motorboat covers the distance between two spots on a river in 8 hours and 12 hours downstream and upstream. So downstream time and then upstream. So whenever you come down the stream, what happens? Two velocity gets added up. U plus V gets added up, right? And whenever you're going to upstream, so you are going to really strain against the flow of the river, V minus U. So what is U? Speed of a river. And what is V? Speed of the swimmer. Speed of the man. So this is the downstream and upstream velocity here. Now, how much he is taking time? Now let us consider XB, the distance covered. So both the times it is going to be the same distance covered. So let us consider this is the flow of the river. Flow of the river is like this. Now when he is going to come along the flow, in this direction when he is flowing, how much time he takes? Only 8 hours he takes. So 8 hours he is taking in the flow of the river. So when the swimmer goes against the flow, he will take 12 hours. So how do you write this equation here? So you can write here as the velocity during downstream is equal to u plus v, that is going to be equal to distance upon time. Time is going to be equal to 8. This is equation number 1. Velocity during upstream is equal to v minus u is equal to x by 12. This is equation number 2. Now we need to solve these two things. Just add both of them. When you add both of them, 2v you will get is equal to x by 8 plus x by 12. Now this is the equation you will get here. And the next time you can subtract both of them and you will get another equation and you will be able to solve both of them. So this will become, when you do the LCM of 24, so it will become 5x is equal to 2v. Then you can do this calculation as x by v is equal to x, and then v you bring it down. So you bring this one up here, 48 divided by 5. So this is the main equation you get here. What is x by v? What is v? V is the velocity of the man. So it is the speed of the man in the still waters. What is x? The distance he is going to travel. So distance upon time, distance upon velocity, this whole thing itself is going to be equal to time. Time taken is going to be equal to distance upon the velocity of the man. Velocity of the man. So it's going to be equal to 48 by 5. If you calculate itself, it's going to be equal to 9.6 hours. So you get here time is going to be equal to 9.6 hours. You will get here, right here itself. So this question comes to an end. You can easily calculate here. Question number 7. Car A is traveling on a straight level road with a speed of 60 km per hour. It is followed by another car B, which is moving with a speed of 70 km per hour. When the distance between them is 2.5 kilometers, car B is given a deceleration of 20 kilometers per hour square. After what distance and time will car B catch up with car A? There is an initial part and then there is a final part of it. First one is, this is a car A. This is velocity A, which is going with a speed of 60 kilometers per hour. And this is also another car A, car B, which is going with a speed of, car B is going to be equal to 70 kilometers per hour. And the instances which they say here, it is after a prolonged time. So both of them in the same direction only it is going, same direction, because it is going in the straight level road, and it is moving with the speed, both of them is moving the same speed with the distance between 2.5. So it looks like this car has already gone so far away now. So this car has already gone so far away with a speed of 70 kilometers per hour. So there is an appreciable distance here. There is an appreciable distance here, and the distance is 2.5 kilometers. So it is 2.5 kilometers, which is here. Now at this point of time, this car, it is now decelerating. It is stopping now. It is bringing down the acceleration. So with the deceleration of 20 kilometers per hour, it is now applying brakes. After applying brakes, this speed is going to come down. When this speed is coming down, this is going to anyhow come and catch it up. This is going to again catch up here. So at one point of time, this car is going to slow down. This car is anyhow going to have the same 60 kilometers per hour. It is going to meet. So now they are asking when and where it will meet. So after what distance and the time it is going to catch up. Very simple. First of all, this is not here now. This car is already gone here. Put this car into rest by applying 60 kilometers per hour opposite. So this is going to be at 0. It's going to be rest here. So apply here. Again 60 you apply here, kilometers per hour. So 70 minus 60. What will be happening? The total velocity is the effective velocity. relative velocity of B with respect to A, that is going to be equal to 70 minus 60, 10 kilometers per hour. So the initial velocity for us, it is only 10 kilometers per hour. And the distance is going to be equal to 2.5 kilometers. Then it is now decelerating, it is now stopping, it is now bringing down the velocity. This is already we are putting at rest. Now we are trying to bring this car, it is now slowing down from the initial velocity, and with the speed of this much, now it is the distance of this much, now it is trying to slow down. When it is trying to slow down, the retardation, acceleration is given here as the value which says it is already 20 kilometers per hour square. So 20 kilometers per hour square. Now it is asked what is the time taken. So we can calculate with the formula S is equal to ut plus half at square. This is retardation minus 20. So what is u? 10 times of t minus half into 20 into t square. Distance, what is it is? 2.5. So you can make an equation out of this one. If you divide this 2.5 with everything, you will get here as 1 equal to 2 divided by 2.5, 4t, and divided by this one also will get cancelled out. It is going to be 10 here. It is again 4t square. So the formula will be 4t square minus 4t plus 1 equal to 0. So 4t square minus 2t plus 1 is equal to 0. So you can separate into terms. So it's going to be equal to 2t plus 1, and here also 2t, if you calculate, it is 2t plus 1. So 2t minus 1 it will become, here also minus, here so also minus, so it's going to be equal to 2t minus 1 will be the answer. So that's going to be equal to 0. So time is going to be equal to 1 by 2 hours. So once time is going to be equal to 1 by 2 hours, after half an hour it will meet. Where it will meet? What is that distance the car would have already traveled? So it is asking after what distance and time will car B catch up. So car B is going to be the velocity. Velocity is going to be equal to 70 kilometers per hour, and time is going to be equal to 0.5 hours. And what is the distance it is traveled? Distance is going to be equal to velocity into time. So 70 into 0.5. So you need to multiply and get this answer. So you will get an answer as 32.5 kilometers. Now it cannot be, this formula will not be able to put because it has an retardation. We need to put the retardation also. So we will just take the same format into a little more elaborate one. So velocity, the initial velocity is 70 kilometers per hour, and then time is going to be equal to 0.5 hours, and the retardation is minus 20 kilometers per hour square, and distance is equal to question mark. So S is equal to ut plus half at square. So 70 into 0.5 minus half into 20 into 0.5 the whole square. So why it is minus? Because it is minus, acceleration is already coming here. So you will get here 35 minus, if you put this whole thing, you will get 2.5. So that is going to be equal to 32.5 kilometers it will be there. That's the distance. Question number 8. A train is moving with a velocity of 30 kilometers per hour due east, and a car moving with a velocity of 40 kilometers per hour due north. So you find a train is going towards east with a speed of velocity of a train, it is 30 kilometers per hour. Whereas at the same time, a car is going due north with a speed of Vc is equal to 40 kilometers per hour, as given here. What is the velocity of car as appears to the passenger in the train? So the passenger in the train is going to see. So it is asked, we see the train, the velocity of car with respect to train, how much it is? That is the question mark here. Now we can easily do one thing. Now this is a train velocity. Impose equal and opposite here, minus 30 kilometers per hour. You can put for Vt, so that this train is brought to rest. If you bring the train into rest, you need to put for this one also equal and opposite. Same minus 30 you need to put kilometers per hour, so that this one and this one is getting cancelled. These two, 140 and 30, will have a resultant here. So you will have a resultant coming in this direction, and you will be able to see the angle theta here. So what is the velocity here? Now velocity of the car with respect to the train, that's going to be this velocity, resultant velocity. So resultant velocity Vct is equal to under root of Vc square plus Vt square. How Vc square? This is Vc square. And what is Vt square? This is same Vt square. You have a triangle here. The same parallel here is, this is parallel here Vt, and is also here. So you can calculate here as 40 square plus 30 square under root. So it is 1600 plus 900 under root. So you will get 50 kilometers per hour will be the value here. So this one is already given here. So 50 kilometers per hour. Now you need to find out the angle here. Tan theta is going to be equal to Vt minus Vc. What is Vt? It is 30 upon 40, that is tan theta. Theta is equal to tan inverse of 0.75. Now you put 0.75 and put a tan inverse, you will get the calculation as the exactly the same answer you will get here. So when you put this one, you will get it as 36.52 you will get. So that you can use the calculator also and find out the value of, just type 0.75 and press tan inverse in a scientific calculator, you will get this answer. So now this is going in which direction here? This is the east, this is west, and this is north. It is going towards northwest direction. So it is northwest direction. So that is the direction here, and this is the speed here. We are going to the next question, question number 9. Rain is falling vertically with a speed of 35 meter per second. There is a rain which is falling here, the speed of 35 meter per second. A woman rides a bicycle with a speed of 12 meter per second in east to west direction. So from east towards western direction, this woman is traveling. This is east and this is west, and she is traveling with a speed of 12 kilometers per hour. Velocity of woman is going to be equal to 12 meter per second. 12 meter per second. Now once she is moving like this, what is the direction in which she should hold her umbrella? Which direction she will be holding her umbrella here? Now since the rain is already falling here, let us put this woman into rest. Put her into rest by imposing opposite velocity against her. So put here it is going to be minus 12 kilometer per second. One time you need to put for her itself, another time you need to put once again for this. So we are again putting again 12 meter per second. So this one gets cancelled out. So you get here the rest of the velocity is, you get a resultant here. This will be the resultant. So if you see the resultant here, this will going to be the angle, this is going to be the angle. She will hold that umbrella somewhere here like this, so that she will not get drenched. When she is traveling, she need to hold that umbrella in this direction. She is traveling in this direction. This will be the direction of angle theta here. We need to just find out angle theta. So it is going to be velocity of rain, it is 35 meter per second, and velocity of women, it is 12 meter per second. And here tan theta is going to be equal to opposite upon the adjacent. So opposite is 12 upon, you can write it as velocity of women and velocity of rain, it is 12 upon 35, that is tan theta. So tan theta is equal to, you will get this one as 0.342 you will get. So what is theta is going to be equal to tan inverse of 0.342, then it will be equal to 18.8 degrees something you will get, approximately equal to 19 degrees you will get. So that is an angle in which he has to hold the umbrella. So that same answer you will find here also. So it is already at an angle of 19 degrees. She will hold towards the west. So this is the western direction. In this western direction, she will hold the umbrella like this. Question number 10. A person moving westwards with velocity 4.8 kilometers per hour. Rain appears to fall vertically down with a speed of 6.4 kilometers per hour. So a person is going in this direction here with a speed of 4.8 kilometers per hour. So we can call it as velocity of a man is this one. And the rain, it is appears to fall. It is written here, the rain appears to fall vertically downwards. So vertically downwards is velocity of rain with respect to the man. So it is a relative velocity is given here as 6.4 kilometers per hour. Find the actual speed and direction of the rain. So we need to find out what is the exact speed of the rain here. Now this is a relative velocity. Let us try to put equal and opposite for this person to make him at rest here as minus 4.8 kilometers per hour. One time you have put here, so these two get cancelled out. One more time you need to put for the rain also. We don't know what direction is the rain, so anyhow we will put one more time for the rain also as again 4.8 kilometers per hour. So we have put here. Now this is the final resultant. This is the final answer. If this is the velocity of the man, and what should be the velocity of the rain, so that the resultant will come here, you will get the rain velocity somewhere here. Then only the resultant will come here. So somewhere here if it is there, so it will make this one to be falling here like this. So this will be the velocity of rain. This is the velocity of man, and this will be the way in which you will be able to get. And here you can make it as an angle theta here, because the rain is falling like this, and here is going to be that angle theta. So what is the velocity of the rain? The velocity of the rain is going to be equal to, now this is 4.8, the 4.8 can come here also. This is 4.8 and this vertical is 6.4. So here you can write here as velocity of the man is going to be equal to 4.8 kilometers per hour, and the relative velocity of this one is going to be equal to 6.4 kilometers per hour. And what is the velocity of rain is going to be equal to question mark. So it's going to be equal to velocity of this one, the whole square, plus velocity of the man whole square, 6.4 the whole square plus 4.8 the whole square. So once you do this finalizing thing, you will get the find an answer of the velocity of rain. Alright, now that will be equal to 8 kilometers per hour you will get. That's going to be equal to 8 kilometers per hour you will get. The next one is the theta value. So if you want to find out the theta value here, this theta and this theta, so make this one here and you will be able to get this. Tan theta is equal to this upon this. What is this vertical? It is velocity of Rm upon this one is going to be equal to velocity of the man. So it is 6.4 divided by 4.8, that is tan theta. That is going to be equal to 4 by 3. So tan theta is going to be equal to 1.33. So theta is going to be equal to tan inverse of 1.33. So you will get here, finally theta is going to be equal to 53.7 degrees you will get. If you put 1.33 and put a tan inverse in the calculator, you will get this one also. Okay, with that this problem gets into the final result here. Question number 11, this is the last question. A ship is streaming towards east with a speed of 12 km per second. So this is the velocity of the ship. It is 12 meter per second. A woman runs across the deck at the speed of 5 meter per second in the direction right angles to the direction of the motion of the ship. So this woman tries to run like this. Velocity of the woman is equal to 5 meter per second. That is towards north. So this is northern direction, this is eastern direction. What is the velocity of the woman relative to the sea? Now here you need to be a little careful about this particular question. This entire thing happens in a huge boat. So this is going in this direction. Once it is going in this direction, you will definitely get the back pull. The back pull will always be there, and the woman is running in this direction here. So what is the velocity of the woman related to the sea? Somebody is seeing from outside. What is the velocity of the woman? You need not take a -1 and all these things. Everything is happening inside the boat itself. Totally inside the boat itself. The woman is traveling here and it's going to be, she's running in this direction. So this will be the resultant here of two velocities. One is Vs and Vw. So you get here as a velocity of the woman with respect to the ship. So if you have just a resultant, you need to find out. You have to just try and find out the resultant. The resultant of velocity of women with respect to this one is going to be equal to Vs square plus Vw square. It is 12 square plus 5 square under root. So it is 144 plus 25. It is 169. It is 13 meter per second is the answer. You will get 13 meter per second is the answer. And what direction it will be getting? So you need to find out the theta here. So theta you can easily calculate. So theta is going to be equal to here. So tan theta is going to be equal to velocity of women upon velocity of the ship. It is going to be equal to 5 by 12. So 5 by 12, it is going to be equal to 0.416. So theta is going to be equal to tan inverse of 0.416. That will be, theta is going to be equal to 22.4 degrees. This will be north of east will be the direction here. So with this, the numerical of relative velocity, it is getting over. Now if you look at this numericals, so you get here 8 to 11 numerical. This is dealing with the directions, different directions. Now first to 7th numerical, it is all dealing with the same, either opposite direction or the same direction. But here it talks about angle here. So all the angles are already coming here. The answers are all getting angle here because it is talking about two different directions accordingly with an angle. So this is a simple numerical. These are all not difficult, but it is simple Okay, thank you.